If you saw the elevator sign, you might have thought that I was going to speak today on the evolution of beauty. And I don't know anything about it, so are there any questions? Fortunately, we have somebody here who does know something. We have this confusion that there are two Gordons, but since he's only 6'3", we call him Gordon the Short to distinguish us. I was thinking as we talked a little about this that Gordon's many wonderful talks so far could be summarized as the beauty of evolution. And I think we're about to see whether this is more than just a play on words. Gordon.
Thank you, Andy, and thank you for coming. Yeah, there's Gordon talking about evolution again. Okay. But that's my life. It's interesting, people typically say, oh, evolution or beauty is this in the mind of the beholder. And therefore, it's uninteresting, it's idiosyncratic, and let's go on to something interesting. Well, beauty has to be, unless you think there's some abstract concept out there hanging in the world, ready for somebody to evolve enough to be able to appreciate it, evolution of beauty has to be in the mind of beholders. Where else could it be? But that makes it extraordinary. Why do minds create some sense of beauty? Because it takes neural machinery to do that. There's no free beauty, just like no free lunches. There's no free beauty. It takes a lot, and there's always competition for neurocircuitry because the brain has got a lot of things to do. Why would you take time to do all this thing called beauty? What's it for? So I want to try to explore this with you. And despite what you might think from the title of my talk, I'm not going to talk about when. I'm going to talk about why and how, because when doesn't actually have an interesting answer, as we'll see. But I want to explore why and how did brains do this. And the way I want you to think about it is that a complicated organism like us, you're moving around in the environment, and you encounter situations. And you evaluate the situation, and what the psychologists call affordance. But for us, we'll say, what's in it for me? So you encounter a new situation, and you evaluate it in the sense of what's in it for me. And you're bringing a lot. An organism will start with a certain amount of what's in it for me that's been programmed in evolutionarily, but the vast majority of it will be that the organism has had experiences. It has expectations about what the environment is. And if you know anything about statistics, I'm describing that this organism I'm talking about is a Bayesian statistician. He or she has some prior notions about what the environment is like and how to evaluate a new situation, and then takes that into a situation and moving on ahead. So we're talking, and some organisms very simple. There's insects, mosquitoes, that the only thing they're able to detect out there is the sound produced by the wings of another female mosquito. And that's all it takes. That's all the world is out there. But we're not like that. We're very complicated, and we're evaluating a lot of things. So I'm imagining we are Bayesian statisticians, and we're going through, and each time we encounter something new, we ask what's in it for us and respond in that sense. So that's what I'm going to start with, and we'll do this. I've asked, a lot of these red bulbs are all around the town now. And I've asked a lot of people, are they beautiful? And everybody says, yeah, they're really beautiful. And the red is beautiful. But is red beautiful? some time ago, Spaniards came back from the New World with some beautiful little red fruits that they saw the Indians eating, and tried to introduce them into the cuisine of Europe, and the Europeans wouldn't eat them. Why wouldn't they eat them? What was the affordance when you saw red? Light nightshade. It's poison. And as a matter of fact, the little red fruit I'm talking about was the tomato. And it is a member of the nightshade family. So you had a prior expectation. We don't look at tomato. We find you wouldn't eat tomatoes, Well, it makes every little bit of sense as to what their experience was of the environment. And it took a while for the tomato to get embedded in sauces and all sorts of things before the people there would be willing to eat it, so that they had a different prior. Red fruit meant nightshade. Here's another nightshade. So, but that's not all there is. Red has a lot of complications. Red sky at night, sailor's delight. Red sky in the morning, sailor's warning. There's the prior. The sailor brings to the situation a background information of what red in the sky at different times of the day means. So the same thing with at sunset, the red in the sunset. This can be beautiful or awful depending on where you are. Most of us, where we're watching it, and the sailor in the ship already knew where it was going. But when you see red sky at night, are you where you want to be when it's going to get dark? Which in the tropics is very soon. The sun goes straight down. There's no twilight. And we're tropical land. Remember, there's no twilight in the tropic. It goes down. And I've worked a lot in the tropics, and we don't see very well at night. All the major predators do. And if you're out there, you want to pay attention to the red sky at night, because if you ignore it, you might find yourself out in the middle of the savannah surrounded by a pack of hyenas, as a friend of mine did. And who's a little late in getting back, and he started throwing stones at them, and luckily they were very nervous to stones landing behind them, but he got himself back okay. He was there able to tell me about it. But so red is very complicated, where you are, what you're looking at. Or take another example. You're somewhere and there's a lot of red on the ground in front of you. Well, this could be you've just had a battle with somebody, and that's the blood of that person you just killed. Marvelous. But it might be yours. And it's going to be so. Our responses to red are dramatically variable, and this may be why fire hydrants are now blue. Remember they used to be red? They've changed to blue because we have much simpler responses to blue. But let me back up even a little further to red. What is red? And if you go there's no red out there. I'm seeing red. No, there's no red there. There's no red molecule. Strawberries aren't red because they got a lot of red molecules. The sense of color, of redness, is something that's created in the brain. And we have several receptors that have different reflective, absorptive properties, and taking three of them together, which what we have, the brain puts together and creates a sense of color. There's no color out there, but my brain tricks me. I see all that color out there, but the brain has produced that. There's no color out there. It's all the creation of the brain. And so not only is it in the mind of the beholder, look what the mind of the beholder has done. Isn't it rather astonishing? But why? What do you get out of seeing colors? what the information you can gather from the environment is much, much richer. You learn a lot more. It's advantageous to be able to see color, and you can do all sorts of things. Learn more about the environment, make more intelligent decisions. That's why it paid for minds to do that. And let me just illustrate it by one example that I think captures it. You go to you're interested in birds, and you go buy a new bird book, and you open it, and all the illustrations are black and white. Good luck. A lot of them you'll get. Some of them you'll struggle, and some of them you won't. And also look at, a field guide to the flowers, and it's all black and white. No, and we evolved that sense of color long ago. Before we got around, there were bees that have senses, and birds, and and you got all these colors. So we evolved a sense of color in a world that was already full of it. We didn't. It was already there, and we just tapped into it. But the point is that building on these things, like what the brain has done, is to create a sense of color. Is costly, but just look what you get for it. And just imagine trying to navigate in the environment. Well, and a lot of animals do. That they have, we just have three, and those molecules are the same ones used by all animals that detect light. It's one of the most conserved things in evolution. Most mammals, which are nocturnal and adult, have only two. And so they don't get the same thing, and all that wonderful red of the cape of the toreador. Bulls don't see red. That's all for us, we think that the bull's really responding to. Well, it isn't. It isn't. These things, the brains create a sense of beauty because it has benefits in terms of survival and reproductive success. That's the whole. So what I'm telling you, and there's Gordon doing it again, beauty is an evolutionary ecological concept. And the world I want you to think of is the ecological theater and the evolutionary play. That's what's going on, the ecological theater and the evolutionary play. Now, the problem, of course, is there isn't one ecological theater and one evolutionary play. There are thousands and thousands of them. And even with a species like this, there's a number of us because we each bring different priors to the situation. But beauty is an evolutionary ecological concept. That's where it comes from. And it's not just beauty. Let me give one other example to show how general this is. And that is in the sense of taste. And sugar's sweet, right? Wonderful sugar sweet. So let's go to our local biochemist and ask her where in the molecule is the sweetness. And she'll say, well, it's not in the molecule. I can't show you anything. And in fact, she will show you a bunch of other molecules that we think are sweet. And they don't have the same characteristic. Sweetness is up here. And the reason it evolved to be sweet is that it's nutritious. Glucose, sucrose, those good things, we want to go for them. And so through much of human history, and it's hard for us to understand in our little bubble, starvation was a really big thing. When there was resources to eat, you gathered a lot and laid on for the starvation periods and enabled you to last longer. The problem now, of course, still in many parts of the world, the starvation does come. For us, it doesn't. And so we laid on the resources for the starvation period that doesn't come. And we try to have a diet. One of the best ways to make a lot of money is to write another book about how to do a diet, because they never work. They never work because we're so compelled by this. We want them, and it's sweet. But does a vulture think sugar is sweet? the smell of rotting flesh. Oh, good, I'm going to go there quick before the bacteria get it all. No, it has a totally different. So I want to emphasize here that the sense of beauty, and now in other sensory modes as well, is ecological. And to understand what an organism thinks is beautiful, you have to ask, and what kind of environment does it live? How does it get food? What does it eat? How does it escape from predators? How does it try to raise babies and all that sort of stuff? You can't begin to understand anything like the sense of beauty or the beauty of odors or musical sounds. You have to go back and ask ecological questions. And so to try to understand beauty in the absence of this, you don't get anywhere. It doesn't make any sense. So what I've been talking about now then are things that are very, very recent in how we're doing with it. But there are some things that I think are a bit more deeply embedded in us. And I spent a lot of time doing that. I spent a lot of time, and this is also summarized in my book, Snake Sunrises in Shakespeare, How Evolution Shapes Our Loves and Fears. And that's something I decided, let me see where we evolved in Africa and when our brains tripled in size and we became human. What was the world like and how would we have reacted to it? So my wife and I made our first visit to East Africa many decades ago, and I had one particular goal. If I had lived back then, when our ancestors lived there and our brains tripled in size, where in that matrix would I have wanted to be? What would the good combination of resources, water, trees that provided shade, and where you could get at night? Because where did our ancestors sleep at night? In trees. Even today, there's only one primate that's other than us that sleeps on the ground. The male gorilla. It ain't safe on the ground. And our ancestors either slept in trees, as almost all, or in the cave on the cliff. And that was only really good when you had vented and tamed fire, and you could have a fire at the entrance and keep all the animals off. So we were in this environment, so this is why, looking at, is there a legacy then that what we found beautiful and what was beautiful in the environments that would have sustained us back then? So I spent a lot of time working on that, studying what we prefer in trees, and that I had wanted to have a tree being shown. I guess we didn't get that. Beautiful acacia, spreading African acacia tree. With these wonderful layers, and those are the trees. And when you're looking for a trip to Africa, what do they have? A big picture of one of those out there, right? That's where you want to go. But most of East Africa, the trees don't look like that. You think that's all there is? No, that's very favorable places where this combination of resources. And so those are beautiful. And I've done a lot of tests of what people think is beautiful for trees. And I did some work saying, well, let's see, when painters are painting pictures of heaven and hell, why do they paint the trees? And this is very interesting because we don't have any information from people who went to either of those places and came back and described it to us. So these are inventions of the human mind with no feedback from anything else. And there's no beautiful savanna trees like that in hell. They're awful, gnarled. And so there's this beautiful sense of trees. And I've done a lot of work with Japanese gardens, which tend to create trees that are spread and things like that, and imitating the kind of trees that we really found beautiful in Africa. So those are a trait that I think is lasting from time, because that's something that hasn't just changed. So some of these senses of what's beautiful may have some temporal permanence to them. And another one, which I'm absolutely fascinated with, I'll talk a little bit about, and that is flowers. Why are we nuts and think flowers are beautiful? We don't really eat flowers. Well, I love zucchini blossoms. Okay, I've had them, and zucchini blossoms are great because they have male and female flowers, and you can take off all the male flowers. They don't influence anything. And besides, with zucchinis, there's only two kinds of people: those that don't have any and those that have too many, because they're so perfect. But flowers, and it really works. It's known that if you bring flowers to somebody in the hospital, they get better faster. It really, really works. And so one of the best things you can do is take flowers to somebody in the hospital. So why do we care about flowers? And again, you don't want a black and white flower book. You don't want the colors, okay? So why is it that we're so crazy about, and why does it work? Well, if you're out in an environment, flowers are a wonderful indicator of a complicated world out there. And when everybody's green, plants don't stand out. But this is particularly in more complex tropical environments where there's just a lot of different plants. But when they come into flower, they really stand out. You know exactly where they are. And if you remember where they are, what comes after flowers? Fruit, right? Fruit. So by remembering where flowers are, and in a complex environment, you have valuable information where resources that you're going to want are going to likely to be in the future. So this makes every bit of sense then why we are so attached to flowers. And again, our brains not only attract us to flowers, but make us good to go with, to respond to the flowers. There's health benefits which we can measure now when we take flowers to people in hospitals. And then, of course, we then use flowers to embellish our own. We start competing with flowers. And the flowers don't win. The flowers don't know what's going on. And neither do dog and cat shows, that the dogs and cats know what's going on. Who wins? We do. So we are embellishing by taking advantage of the stuff that we really like. We get social enhancement, and that's another whole story that I'm not going to try to go into. But that was what makes our responses to these things as human beings so incredibly complex, because we use them in all sorts of ways. So I've talked now, okay, let's sort of summarize a little bit that beauty and wonderful smells and other sounds are ecological evolutionary concepts. They don't make any, if you want to know what an organism might consider beautiful, you ask a whole bunch of questions about its ecological nature, without which you can't get anywhere. And now does it mean we've now discovered what beauty is? Well, what we have is a snapshot in time. It hasn't stopped evolving. We're continuing. We're getting new stuff. It's going on, and somebody's going to give us talk 20 years from now. It's going to say something different because our sense is going to have changed. So we're always. What this says is this is a snapshot in time, and that it's going to keep evolving. And we don't know what's going to happen. We're getting all these new signs from the telescopes and everything like that, new coming in. That may lead to new senses of beauty. We just don't know. But the point is that we can't say, okay, now we got it and it's stopped. No, it hasn't. But the real problem now with ecological theater and the evolutionary play is that the ecological theater is changing too fast, and the evolutionary play can't keep up with it. And that's the big problem we have in the world today. We are changing the ecological theater faster than the evolutionary play can keep up. And evolution isn't going to bail us out on this. We've got to do it with our current minds, and that's the evolutionary changes in the past were slow. They will keep up. Today they're far too fast, and that's our big problem. But aesthetics is going to continue to evolve. So when did it start? It probably started way back early in the evolution of life, where the process I've just talked about, animals had to select habitats, do those sorts of things. I think the same processes would probably have been operative. The same functionality of beauty, of smell, whatever, has been operative all along. So when did beauty start? It started along with life. But the problem is, when we go to these other organisms, ask a bird visiting a pretty flower, how do you feel? We have no way of asking that question. It's closed to us. That doesn't mean the bird doesn't have emotions, but how do we know what? We haven't figured out how to answer that question yet. We may never figure that out. I don't know. I see no reason to believe that we can answer every question we can pose. At the same time, I'm not the one who's going to tell you which ones they are, because the history of science is the ability we can now answer questions we couldn't answer sometime before because we got some new tools. But this may be forever close to us, because maybe someday we'll be able to talk to a bird and say, how does it feel? And it'll say, this is how I feel, isn't it wonderful? But right now, we know that they've got emotional responses. We can do various things, how hard they'll work to do different things. We can tell that it really is really, really important, but we don't know how to ask that question. But so I've talked just about us, but that's because we could understand us and we could ask questions and we could understand one another. But that's let me just tell a story which may help illustrate this. I had a grandson in Vancouver who's now a grown man, but he would come down to Seattle to visit us, and he loved I read a lot to him. He loved to have me read to him. And one of the books he really wanted me to read every time was called Alaska's Three Bears. Black, brown, and white. That Alaska has 3 species of bears. And here's the story. The bears are walking, and they happen to encounter one another walking in the environment. So they're walking along, and they come to a glade with the sunshine and the butterflies and berry bushes all over the place. And the black bear says, "Oh, that's beautiful. I want to stay here." So the brown bear and the white polar bear looking, doesn't look very beautiful to me, so long, and they go on walking. And a little while later, they come to a dashing stream with salmon jumping around and looking, and the brown bear says, "Oh, is this beautiful? This is where I want to be, and I'm gonna stay here." And the polar bear doesn't look very interesting to me. Doesn't look very pretty to me. So on he goes, and comes to a seashore with floating ice and seals out there. And the polar bear says, "God, this is beautiful." And he jumps into the water and goes out to start hunting seals. Now this is a story, but it captures. If you want to understand the concept of beauty, and in any organism, us and all others included, you have to ask a bunch of ecological questions. How does it live? What does it eat? How does it pursue? How does it defend itself from predators? How does it raise babies? All these sorts of things. That's the context in which beauty evolves. And there's no abstract sense of beauty out there that's independent of all of this. And so any attempt to try to understand beauty and what it means and how it's evolved without asking ecological questions doesn't get you anywhere. You just can't understand. And the beauty of this is that this doesn't give you a simple one answer. It can account for the incredible variability that the different things that organisms find beautiful that we would find ugly and everything like. So, a common set of mechanisms and a common set of purposes yields an incredible richness of variety. And that's the wonderful, wonderful thing about evolutionary biology. Some common mechanisms, some common processes and purposes leads to incredibly rich and varied stuff. So as we think of this and look about it, the wonderful world into which Darwin has led us is rich and variable and incredibly, it includes beauty and all these lovely, lovely things. And it all happened without us having to understand what it was about. We didn't necessarily know what we were doing or understand, but you didn't need to know. All the marvelous sort of domestication of plants and animals done before anybody knew anything about genetics. They only knew one thing. Offspring tend to resemble their parents. That's all they knew. Look what they did. Look what they did. And, you know, you didn't need to know the rest. And the marvelous world of the domesticated plants and animals, everything we live in, that's the only genetic knowledge they had. And we have less deep understanding of what we're doing and why we're doing it than we like to imagine. We've got an autonomic nervous system that does all sorts of stuff, and we don't know what it's doing, we don't understand it, and we can't control it, and it goes on and does its thing, which is lovely because all that stuff we don't have to worry about. It does it, and we can then put our brains to things that we need to look at and really are important for us to look at. So let me close by saying the wonderful world into which Darwin led us couldn't be more exciting and beautiful. Thank you. So, we have some microphones.
It seems to me that a lot of people that have very complex lives and a lot of stress, when they want something to cut from that, go into gardening, some form of gardening, where there is a little more, from their point of view, a little more predictability with plants. Plants have unpredictability from time to time, but from our point of view, there's a calming effect working with plants and especially with flowers that cuts into the high tension of perhaps an occupation.
Yes. Gardens are fabulous, and gardens are applied changing the environment to make it even more attractive, right? And there's different gardening traditions, and some of them, like the Japanese gardens, are based primarily on tree shapes, which is why I got especially interested in them, because there wasn't so much on flowers. But again, as I mentioned, we love flowers, and flowers is valuable to pay attention to flowers because they signaled something that helped us in the future to get. So we embellish and make flowers and do incredible, and we change flowers and we make flowers bigger and better and lasting longer and all sorts of stuff. We make them even more attractive, and that's what domestication does to plants and animals. So yes, there's no question, and we know a lot about the fact that going and sitting in gardens can have a very strong therapeutic effect. They really affect health, and it isn't just that you feel good. You feel good because there's wonderful things happening to you. So the gardening traditions are an important part of exactly what I've been describing, and that's why we spend so much money making gardens and spend so much time going and sitting in them. Thank you for the very good question. Margot.
Gordon, you didn't talk about symmetry. which is an aspect of beauty.
Okay.
But there are a number of mate selection studies that indicate
Yeah,
that
okay.
given a choice between two
Okay.
possible partners, one is not as symmetrical as the other, they will always choose a more symmetrical partner.
Yeah.
And the hypothesis seems to be that symmetry equates to overall health and reproductive health.
Yes, as a matter of fact, thank you for the question, because I had intended to mention that and didn't. This is one of the things of the human sense of beauty that we know very much that relates to symmetry. And a slight asymmetry in a face, we very quickly find it ugly. And there's a combination of one or both reasons why that's likely to be adaptive. One, that may indicate genetic problems. So the genetic development, you didn't get the development quite right. And so there's a little bit of asymmetry. The other is, this may be the product of disease that you're looking at that has created a slight bit of asymmetry. So the combination of both of those means that's not somebody you want to get associated with. And we will, of course, do an enormous amount of plastic surgery and stuff like this to correct every little bit of asymmetry. So, this is, thank you for bringing it up. I forgot to do it. That's one example of how a sense of beauty that we have can be definitely related to adaptive. It is not a good idea to get associated with this person with the asymmetry.
Well, even cockroaches tend to select for more symmetrical partners.
Right, I mean,
It goes all down the chain.
Yeah, right. Yeah, it's a wonderful thing, and that's one of the things that is so clear, because we know exactly what's going on there. And a lot of what we have, when we get into human being stuff, it's a lot of complications come because we compete with it and all sorts of stuff, So.
Follow-up question, Gordon. Japanese gardens, however, are famously asymmetric. In other words, they don't like things that are symmetrical. Trees are contorted, and almost everything is asymmetrical in the Japanese garden.
Okay, the Japanese gardens are really very, very interesting because what is involved in those and changing them, they get to look a lot like savanna trees. African savanna trees. And I've done tests of what people find beauty in trees. And one of the most important features than what you see in the Japanese trees is the trunk bifurcates very low down. And I've done studies with people's assessment of the attractiveness of trees. And one of the very positive things is the trunk bifurcates very low in the ground. And I experienced this when we were working in East Africa measuring trees, and I discovered how easy we could walk up on a lion without seeing it. And so when my wife and I started walking out and measuring trees, one of the first things I did, and I'd never done this before, looked around which one's the easiest to climb. And I parked that. I never had to do it. But the other thing is the layerings. And doing so, there are other things besides the symmetry of the tree that relate to what is attractive about it, and a lot of what we're done with the evolution and selection of trees, and the Japanese, to get those, you've got to trim every branch every year. I mean, there's an enormous amount of work to create that sort of symmetry pattern, and you're probably thinking, but Gordon, that ain't all about trees. How about these beautiful spires going all the way up? Okay. There we're bringing another aesthetic thought to it. We're talking about salvation. And up is always good. We have uppers and downers. We have highs and lows. And in all cultures, where you want to go is up, and where you don't want to go is down. And that also plays into the kind of trees we select. So we select those, then we also, the towering cypresses and stuff like that we also regard as beautiful, that are dramatically different. So when we're asking what's in it for us, the Bayesian encounter, we're encountering and thinking about very different things. So we're a pretty complex animal, which is kind of nice, I think, really. It's rather fun.
Many years ago, in the late 1990s, there was a book published, a fiction book called The Strangeness of Beauty. It was fiction. It was a Japanese author who happened to be from Seattle. And I don't quite remember the story, but the character goes back from, I think, from America, definitely, to Japan. And whatever the story was, but the main theme was the beauty that people insisted on in Japan.
Yeah.
Everything had to be, if you put down chopsticks, they had to be not just dropped on the table. They had to be laid in a certain configuration so that there would be beauty evoked, and on and on and on. I mean, the emphasis in the book, I don't remember the story, but boy, I do remember to what degree in Japan, this was in the 30s, it was important that everything was beautiful, the strangeness of beauty.
Yeah. I think was it Lady Murakawa, one of the earliest treatises on beauty, and the Japanese, it goes way, way, way back. And again, that can be very cultural. You know, our sense about that can be very, very complicated. But the sense of beauty, and we crave beauty, that's really important part of us, and that's up here. The brains create that, and the value that it had. Why we have that is that helped us navigate the world and get to places where it was good for us to get. And that's the bottom line of all of that. And we make it do all sorts of other things. We're not going anywhere, but I think it's the same root of that. Yeah.
You have failed to convince me that strawberries are not red. What is wrong with me?
No, there is absolutely nothing wrong with you, because I look at strawberries and they're red, damn it. You know, I know that my mind is doing this to me. And that's the wonderful how beauty is in the mind of the beholders, and that's what the minds do. It's stunning. Because I'm seeing red. I see red strawberries just like you, but my science tells me that there's no red molecules there. And the brain plays tricks. But I'm very happy to see all the colors out there, because it works in terms of, I got the bird guide and it's got all the colors in it. Okay, that may be trivial, learning to identify the birds, but you get the point that the color enriches what you can do out there. So I let the brain play tricks on me. I see the colors out there. I see the color in the birds. I see the color in the flowers, even though if you ask me, I know it's all up here, but I don't need to convince you, because the brain does it to us, and enjoy it out there, you know. I mean, that's what it's about. I mean, I love the beauty of the color of flowers, even though if you ask me, no, there's no color in those flowers, I know it, but hell, I'm enjoying it because it was good for me to enjoy it, okay?
I have a question about the perception of color. My understanding is that humans perceive color because, say your shirt, for instance, absorbs every spectrum color except blue. So I'm seeing it as blue. So why would a bee or a bird see it as a different color? Is it just their brain?
Well, again, with the colors is what's being reflected by these objects. But again, the brain, bees see ultraviolet. And so bees see different. If you want to know what the flower looks like to a bee, we can now show the flowers under ultraviolet light, and we see this is what it looks like to the bee. You know, and again, if we want to watch bees in their dances in the dark, we look under red light because they can't see that part of the spectrum. So we can watch them and learn all about they're doing in what is for them in the dark, but what we can see them. So different organisms have different, and we have these three which we get a color, and our color charts. Birds have 4.
Okay.
We have no.
Are you talking about the rods and cones?
We have
The-
no. The rods and cones. That's we're able to get different wavelengths, but we have these molecules that are in there, the opsins that are absorbing and have different absorptive spectrum, and we have 3. And the brain puts together what's happening to create a sense of color. Birds have 4. We haven't a clue what it looks like to birds, and the bird book. With color, that's how I see the birds. That may not be how the birds see themselves. We just don't know. So this is the wonderful world of how exciting it is and how limited our own perceptions kind of can be, because we have a particular range that we can perceive, and our brain interprets the different spectrum in different ways. And what we call the primary and secondary colors, that's our system. The bird system probably is nothing like that, although we have no way of knowing what it is. Okay, I mean, it's rather exciting, really, but it lets you it humbles you a bit that we have just one particular out of many. We aren't the center of this universe. We didn't invent beauty. Beauty didn't exist for us. It's come along, and our brains create it because it helps us get along better in life. And the fact that it's utilitarian doesn't bother me. Just like Shelley thought Newton spoiled the rainbow because he explained what it was, and as though it was better not to know what it was. Well, I can enjoy the rainbow just as much as Shelley did. And I don't care that Newton said this is what it is. It doesn't doesn't affect their ability. But this has been a big thing in human evolution. You don't want to know. When Benjamin Franklin figured out what lightning was like, electricity, one of the big opposition was from the churches. Is that this you're taking away from what God is doing to punish us, and you shouldn't do that. And the odd thing is that what buildings were being mostly hit by lightning? Churches. They were the tallest. And Benjamin Franklin gave them a lightning rod. Good for him, but they didn't like it. Anyway, we know what the rods we know what the molecules they've got. We know that they've got four of these molecules. We have only 3. Again, we can look at animals and see. We can look at their brains and see what the absorptive molecules are. But we can know that. But what birds look like to themselves, I'll go with the field guide for how they look to me, because that's all that matters to me. But I have to know that when I'm doing manipulations and looking at, I did red-winged blackbirds, and what happens if you color up the red? These things. Well, in these experiments, I'm assuming they see themselves as I do. Well, I don't really know. I'm not sure what I was doing with those experiments. Maybe thinking I was learning something that I didn't. Yeah.
Beauty, as in our own creations, art and architecture is it's not static. It's evolving by us. And when I heard about symmetry, that we have sort of leaned toward or attracted to symmetrical things, we're also at times repelled by them. They can be boring.
Yeah.
And I'm reminded of what Grant Hildebrand said that about what attracts us in evolving art and art, ordered complexity, so that you have more than symmetry in beautiful things, and it's balanced, and we're always experimenting. I'm thinking of this in Japanese art too, because sometimes some of the trends seem kind of compulsive or obsessive, but they're balanced in the larger picture.
Yeah, there's a lot of stuff. order, and symmetry isn't only one form of order. The pattern, our mind is a pattern seeker, because one of the things, if you can find pattern out there, that enables you how to relate to it. And one of the really interesting things is in Jackson Pollock's paintings, which look very crazy. They have a symmetry. They have a pattern to them, and you can look at a Pollock picture and you can pull a pattern out, and that makes our brain feel very good. We can understand something about the world, and we know that he had paintings that he never showed. And you go in his office where they found them, and they don't have he. Whether he understood this is hard to know, but our brain seeks patterns, and because unless we can find a pattern out there, you don't know what you're dealing with. So symmetry is only one thing. That beauty is a many-splendored thing, and I hope I've convinced you that it isn't just one thing, that it's many, many, many things. And it's different things to different people, but there's a common underlying thing that has driven this, and that's what enables us to understand and make sense of it. But there's a lot else going on. Yeah.
Do you think it's useful in talking about color to distinguish between the conceptual and empirical questions you're addressing? To see a strawberry as red, you need certain mental capacity in the brain, but you also need the strawberry. And so talking about where is the color, maybe to ask the wrong question. Empirically, you need both of these things. Conceptually, you can call the color something in your brain or something in the strawberry, but it's really the experience of the brain's interpreting something in the world. Yeah. And so it's no more correct to say, since it doesn't have a place in that sense, well, it's this combination of things. It's just as valid or invalid to say it's in the strawberry that it's in the brain. If you have all of the equipment in the brain, and you're in a room with no light, then you don't experience it.
Yeah, I mean, it's. I had a good friend in the botany department. I taught with him, and he was red-green colorblind. And I remember walking with one of these strawberry plants, and it was in full fruit with all these red fruits all over the place. And he walked up to it, he couldn't see them. He said, "It's not in bloom." And again, this is a very particular thing. So that the important thing is that, yes, it does have an incredible relationship to how we see the world. But what drives it is what residing up here. And the point of my talk is that why the brains evolved to do that at considerable expense is that it enables us to make better decisions on how to get along in the world. That's my bottom line. That's what it's all about. And the fact that it's beautiful, let's enjoy it, because what drives us to do we should be Homo sentiens, not Homo sapiens, because it's feelings and emotions and loves and hates and stuff that drive what we do, and what evolution is building on is those and the sense of beauty. Honey, in East Africa, we now know that how important honey was to human evolution, and probably our sense of sweetness is related to the evolutionary role of honey, and has led to one of the most amazing evolutionary relationships between people and a bird that helps a honey guide, that helps guide them to honey, because we are good at opening combs and stuff in Tree Hill. We're not very good at finding them. The bird is very good at finding them and very poor at opening them, and has the symmetry. But again, it's honey and sweet. And we got our sweet tooth is almost certainly related to the power of honey in human evolution. And it was right on. And what was the drink of Elizabethan Europe? Mead. That's fermented honey. Yeah, right. So we're honey people. And
how do you explain color blindness? Is it a lack of something physical in the brain, or is it a learned thing?
Well, I think color blindness is, these are developmental problems. And when we have, we're sexually reproducing species, and there's a lot of variability, and we get all sorts of stuff. And there's people that don't respond to beauty like the rest of us do. There's all of this is not surprising, but because what sexual reproduction produces is variability, and it misfires, and it misfires a lot. The amazing thing is it does as well as it does to get it. But one of the things we have to recognize is I've described what most of us think is beautiful. There are people that don't think it's beautiful at all. So we're not a uniform, and no sexually reproducing organism is. What that creates is variability, and the whole point of it is variability. That variability is one of the ways we fight against bacteria and other pathogens that have life cycles running around 20 minutes. Those are pretty fierce. And what we know now with COVID, how things that are very simple, evolving really fast, and we have to get new vaccines every year because they keep evolving on us. We're slow reproducers, and there's a lot of stuff that we have to deal with that is evolving pretty fast. And so, but the variability is what helps us. It's also what makes it complicated, because we have pathogenic liars and have all sorts of things that it didn't work out quite right. And it's amazing that it works out as well as it does, as much as it does.
Okay. Just a footnote on Grant Hildebrand. I don't know if he's here. I didn't look.
I don't think he is.
He has a whole book, as you may know, on why what is beautiful in architecture, particularly residential architecture, is based on the prehistoric sort of notions that we need a big grassy area in front of our place because we want to see whether the predators are coming or not. We need a refuge with walls and small windows to protect us from those predators. And those are patterns of architecture that are thought these days to be beautiful. Well, I'd love to have this cozy little room, and I'd love to have this expansive lawn. But the beauty is rooted in some much earlier considerations.
There's a wonderful book that I would recommend to all of you. It's called The Right Space, and it's W-R-I, and he looks at the beauty of that, again, in something that is related to what I've just been talking about, habitat selection theory and how we pick places. And it's a wonderful book, and we probably have it in the library, but it's interesting that with architecture, unlike paintings, that this is a distance you're supposed to look at the painting. With architecture, you're approaching a building, and it's changing as you're coming to, and then you walk inside, and it's terribly different. So there's not a single place you're supposed to see this thing. So perception of beauty in architecture is very complicated because we're moving through it, and you go into it and it's bright and you can't see anything. And then you come out and you're blinded and you can't see anything. So architecture is one of these really complicated things, and then it gets involved in a lot of other things. But his book, The Right Space, I would highly recommend to you. It's a wonderful, wonderful book. Thank you, Bill.
Thank you all for coming, and thank you, Gordon, for your contribution. Thank you.